When you hear the word explosion, your mind compresses it into a moment, a sharp release, a burst of energy, then dissipation. You imagine a boundary between asterisk during and asterisk after asterisk. Noise, then quiet, fire, then smoke, expansion, then emptiness. In your mental model, an explosion is defined by its peak, the instant of maximum violence. Everything that follows feels like cleanup, residual motion, leftovers losing relevance. But that definition is psychological, not physical. Physics does not privilege the dramatic moment. It does not care when something looks finished to you. An explosion is not a flash. It is a redistribution of energy through space. And redistribution is not an event. It is a process that continues as long as energy remains unevenly spread. Which is to say, almost forever. Imagine releasing a drop of dye into perfectly still water. At first, you see structure, swirling tendrils, sharp gradients, motion you can track. But eventually the color becomes uniform, invisible in its spreading. Has the process ended? No. The dye molecules are still moving, still dispersing, still interacting. The system has not stopped, it has only become too smooth for your senses to notice. You call that equilibrium, you call that finished, but nothing was undone, nothing was erased. The original disturbance simply transformed into a new background condition. An explosion doesn't truly end when motion slows. It ends only when its energy is indistinguishable from everything else. And that takes far longer than your intuition allows. You trust your eyes to rank importance. The brighter something appears, the more powerful you assume it must be. A welding arc overwhelms a candle, a star overwhelms a planet, a supernova overwhelms a star. Brightness feels like evidence, immediate, hierarchical, obvious, but brightness is not power. Brightness is proximity, concentration, and timing, nothing more. Imagine two fires releasing the exact same total energy. One burns all at once, a violent flash lasting seconds. The other releases its energy slowly, steadily, over millions of years. Which one looks brighter? The flash does. Always. Because your senses measure energy per moment asterisk, not total energy released. They reward intensity over duration. They privilege drama over accumulation. This bias is so deep that you rarely notice it shaping your judgment. Now stretch this misunderstanding across cosmic scales. A single star pours enormous energy into space, but that energy spreads outward in all directions. By the time it reaches you, it has diluted across unimaginable distances. What you perceive is only the thin residue passing through your eyes at this instant. Brightness, then, is not a measure of how much energy exists. It is a measure of how much energy arrives here asterisk, asterisk now asterisk, in a narrow stream. Something can release vastly more total energy than a star, yet never appear dazzling. It may radiate weakly but continuously, quietly but everywhere. Not overwhelming at any one point, but inescapable across all points. Your intuition resists this. You equate faintness with insignificance. But a whisper that fills an entire planet carries more total sound than a scream heard in one room. The universe does not measure brilliance the way your eyes do. It measures how much energy exists, regardless of how thinly it is spread. And when energy is spread everywhere, brightness stops looking like brightness at all. You instinctively treat light like a message. Something happens, light is produced, it travels outward, and eventually it passes you by, a signal from somewhere else. Temporary, directional. Informative, like a sound wave reaching your ear, like a flash you notice, then miss, then forget. In this picture, light belongs to its source. A star emits light. A flame emits light. An explosion emits light. The brightness feels attached to the place where the event occurred. But this is not how light behaves once it enters open space. Light does not remain tied to origin. It does not hover near the event that created it. It leaves, it spreads, it fills. Imagine standing in an empty, perfectly dark room. Now a single bulb flashes once, just once, and turns off forever. If the room's walls were perfectly reflective, that flash would never disappear. The light would bounce endlessly, crossing the room again and again, filling every direction, not fading because of time, only redistributing through motion. The room would now contain a permanent field of traveling light. No visible source, no ongoing event, just illumination that continues simply because it has nowhere to go. Space behaves far more like that sealed room than your intuition suggests. When light is released into the universe, it does not neatly pass by and vanish. It streams outward in expanding spheres. Every second, the same energy occupies a larger region of space, thinner but more widespread, and unless something absorbs it completely, it remains part of the environment it has entered, not a signal, a condition. This means light from a single event does not mark a location. It reshapes a volume, a growing, expanding, ever-thinning ocean of radiation moving through everything it encounters. If enough light is released, and if it spreads long enough, the distinction between light from the event and the background of space itself begins to dissolve. At that point, you are no longer observing the aftermath from afar. You are immersed in it. You assume expansion weakens things into nothing. Stretch something far enough and it disappears. Spread anything thin enough and it becomes irrelevant. That is how dilution feels in ordinary life. A drop of ink in a lake, heat dissipating into cold air, motion fading into stillness. Expansion looks like loss. So when you imagine the universe expanding, you imagine it washing events away, stretching their traces until nothing meaningful remains. But expansion does something more subtle than erasing. It preserves by transforming. Consider a wave moving across a stretched rope. If you pull the rope tighter while the wave travels, the wave does not vanish. Its shape changes. Its wavelength grows longer. Its energy spreads differently, but the disturbance continues. Now replace the rope with space itself. Replace the wave with light. As the universe expands, the radiation moving through it is stretched. Each wavelength lengthens. Each photon loses energy. The glow cools. What was once fierce becomes gentle. Violence becomes whisper, but nothing is deleted. The energy released long ago does not disappear simply because space grows. It is carried along, stretched with the fabric it travels through. Diluted, yes, but preserved in motion. This is the crucial shift your intuition resists. Expansion does not sweep the past away. It stretches the past across the present. Every region of space grows larger, but the radiation within that space grows with it, filling the new volume, occupying the new distances, remaining everywhere the expansion reaches. The original event does not fade into nothingness. It becomes more evenly distributed, more uniform, more pervasive, less noticeable but more inescapable. Like a sound that becomes quieter not because it stopped, but because it now surrounds you from all directions equally. At that point, you stop hearing it as a sound at all. It becomes silence, even though the vibration continues. Expansion does not end in explosion's influence. It converts a localized burst into a universal background. You are used to observing events from the outside. A storm approaches, then passes. A fire burns, then leaves ash. An explosion happens somewhere else and you watch its effects arrive from a safe distance. Your mind depends on separation. There is the event, and there is you. But what happens when the spreading aftermath never passes you? What happens when the expanding radiation from an explosion grows large enough that no outside remains? At some scale, distance stops protecting you from history. Imagine an expanding sphere of light released long ago. It moves outward at the fastest speed anything can travel. For a while it crosses empty regions, then more distant ones, always growing, always spreading, Eventually, its radius becomes enormous, larger than any structure that formed afterward. Galaxies assemble, stars ignite, planets cool, life emerges, but the expanding radiation keeps moving. At some point, every location that will ever exist lies within the region it has already reached. Not because the radiation chased everything down, but because everything formed asterisk inside its expanding reach. That includes you. You are not standing somewhere watching the fading glow from afar. You are located within the volume that glow already filled long before your planet formed. There is no direction you can look that points away from it. No boundary where its influence stops. No exterior vantage point from which the explosion could appear distant. The radiation does not surround you like light from a lamp. It permeates the space you occupy before any local light sources even exist. You breathe air that condensed inside its aftermath. You stand on matter that cooled while immersed in its radiation. Your entire cosmic environment formed while this expanding energy field was already present. The explosion is not part of your history, the way ancient ruins are part of Earth's history. It is more like temperature, or gravity, or space itself. A condition you never stepped into because it was already there before anything could step. You do not observe the aftermath. You inhabit it. Now the paradox becomes unavoidable. How can something that feels so faint, so quiet, so ordinary, outshine billions of stars? You look at the night sky and see blazing points of light. Each star is a furnace, each one pouring energy into space at an astonishing rate. Gather 10 billion of them and the total radiance should be overwhelming. And yet, the ancient aftermath still exceeds them, not in appearance, in total presence. Your eyes and even your instruments are built to detect contrast, differences, local intensity, a bright object against a dark background. But what if the background itself contains more total energy than all the bright objects combined? Then brightness stops behaving like importance. Imagine walking through a light rain. Each drop is barely noticeable, soft, gentle, almost nothing. Now imagine that rain falls everywhere across an entire continent, uninterrupted, constant, covering every surface. Compare that to a single roaring waterfall crashing into one valley. The waterfall looks more dramatic, louder, more powerful in any one location. But the total amount of water falling across the continent far exceeds what pours through the waterfall. Local intensity misleads you. Distributed presence overwhelms you. The ancient explosion's radiation behaves like the rain, not the waterfall. Every direction you look, space contains a faint glow, weak at any single point, barely noticeable without careful measurement. But it exists